Okay, so this is term 1, week 5, physics, CA. I'm gonna go through it a bit quick because I'm already late at 7 o'clock. I'm gonna go through, and you read the notes yourself. They're on the Google Drive as usual. For anyone who still doesn't have the Google Drive link, it's in the description of my channel, not in the video, not in the description of the video, in the description of my channel. Anyway, let me start. I'm gonna go over them quickly. You can read it over yourself, okay? But I'm gonna go through anything that might be a bit tough. Okay, I'll start أول شيء. This is electricity, so كلها يعني memorize these definitions. The activities, just skip them, okay? If you want, like, you can read them, but no need. Dust particles are attracted to electrified TV screens, okay? It's self-explanatory. Okay, you need to know that when you rub glass, it becomes positive, okay? And if you rub plastic or polythene, other people call it polythene, they become negative, okay? You know that glass becomes positive and plastic or polythene becomes negative, okay? Uh, okay. Generalization, for objects to be charged by rubbing, they must be rubbed against objects of a different material. I mean, obviously, yani. Okay. Electrification occurs easier in dry weathers. Okay, this could come. Okay, in which يعني it could come in the CA. No, these are all definitions. Okay, generalization, there are only two charges, okay, negative and positive. Negative like plastic, positive like glass. When you bring a glass rod into contact with a pith ball, they will repel on the second time they are brought into contact with each other. Okay, uh, this is, I think, here. Hold up. Like here, okay, I didn't draw it here. This is for another experiment, but here for the ball thing, basically you bring it near it, okay. This is what, plastic or glass? Glass, okay. Uh, Yeah, let it touch an uncharged spit ball. Okay, you'll observe that the ball repels after contact. Why is this happening? Okay, being repelled by the rod, the ball has acquired the same charge as the rod. Therefore, we can say the ball is charged by contact. Okay, this is the definition. The above experiment can be repeated by taking a positively charged rod. Okay, same thing. So actually, when you take the charged rod, you touch it with the ball, there are going to be charges that flow. Okay, they're going to try and become the same thing. So like, مثلا, if this is positive, okay, this is going to start losing electrons to here, and this is going to start becoming positive as well. But before they can both be like, before this one becomes negative, they're both positive positive, and you guys know when they become positive positive, they repel. Same thing if it's negative. If you bring it close and it's negative, this one's going to donate some electrons, making this one also negative, so they're going to repel. Okay, maybe they might ask upon which time will it repel. On the second time. Conductors allow charges to flow. Okay, the same experiment can be used. Get the same charged glass rod. Let me change my color to red. Okay, and get a metal rod. If you touch the charged glass rod with the metal rod, it's gonna repel because the charges will flow through the metal, because metal is a conductor. However, if you put plastic, أكيد plastic is an insulator, it won't repel because the charges won't flow through the plastic. Okay. This is to show that the metal is a conductor, so the ball is repelled. Plastic is an insulator, the ball is not repelled. La 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 la. Okay, the metal rod will share its charge with the ball. Sharing a charge over two conductors decreases the electric force. Okay, this is self-explanatory. Okay, grounding or earthing. Okay, this is important. Okay, to earth a charged object means to bring it into contact with a much larger conductor, which may or may not be the plant Earth. Okay, let's say you have a circuit. Okay, this is the easiest way to explain it. Okay, you have a circuit. Okay, and it's opened and it's leaking electricity. Okay, it's leaking electricity. Okay, does it mean if I'm standing in the same room, or if I'm standing on the same ground, okay, am I gonna get electrocuted? Obviously not. These electric charges will flow to the earth, and you guys know the earth is a huge body. Since it's such a huge body, it's just gonna absorb those electric charges like nothing even happened. Another example, your body, your hand, okay, when you touch, I don't know, whatever, this is not hand, okay, واحد اثنين ثلاثة أربعة. Okay, when you touch, I don't know, عندك, oh, I don't know, you could say a battery. Okay, there's electrons flowing in. Those charges will just be earthed or grounded by your hand. The police, why do you still get electrocuted? Okay, that's something else. That's when there's too much charges. But yani, for the most time, okay, to earth a charged object means yani, you kind of like lose its charge. It leaks. So see here, to earth a charged object means to bring it into contact with a much larger conductor, which may or may not be the plant Earth. Okay. Uh, Okay, هلا it's something called induction. Okay, induction is called charging by influence, as opposed to when we did charging by contact over here where we would touch it. هلا it's charging by influence. Okay, it's a process of charging objects without touching. Okay, here's the experiment. Very easy. Two uncharged balls, neutral, neutral. Okay, you're gonna bring a positive glass rod not in contact. Okay, you don't touch. What's gonna happen is this positive charges, what will they attract? Negative charges. So all the negative charges in these balls is gonna flow here. So okay, if the negative charges flow here, what's gonna be left here? Positive, 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 right? Okay, now without removing the rod, okay, pull one sphere away. Okay, the one that you pulled will just be positive. Okay, what happens? Here's the interpretation. The further sphere is positive, the closer sphere is negative. Why? Because the positive rod will attract the negative charges, but those negative charges won't be transferred. Why will those negative charges not flow to the rod? Because the rod is at a distance, it's not touching. Okay, and you can only transfer it if they're touching. Okay, because they won't be transferred because the rod is not in contact with the sphere. Those negative charges will accumulate on the right sphere, making it negatively charged. Uh, okay, Coulomb's law, we'll go through this quickly. Okay, any electric force, or the magnitude of any electric force, is equal to the two charges, okay, Q1 times Q2, their charges, times the constant K, which is 9 times 10 to the power of 9, okay, 9 times 10 to the power of 9, over R squared. R squared is just the distance between the two charges, okay, very easy. So like here they said R is 1 centimeter, okay, they said we have to convert it into meters, huh? Always meters, huh? They gave us R is 1 centimeter, they gave us the force is 5 newtons, they want us to find Q, okay, we know they said that Q1 is equal to Q2, okay, so, and this was a question, I'm just solving it fast. You know that the force, like we said up in the formula, the force is equal to the constant K times Q1 times Q2 divided by R squared. So the force 5, where it's given 5 newtons, so 5 equals K times Q1 times Q2 over R squared. R here in this case is 0.01 squared. Okay, Q1 and Q2, they said that they're equal to each other. They said it's given. Q1 and Q2 are the same charge. Okay, so instead of Q1 and Q2, you could just write Q times Q. In other words, Q squared, right? So K times Q squared over 0.01 squared equals 5. We know that K is Coulomb's constant, 9 times 10 to the power of 9, Q squared over, and you solve blah, 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 blah. Okay, this is just take على هون neutral objects are always attracted by charged objects. Okay, charged objects will attract neutral objects. Okay, a body is electrified when the natural distribution of its electrons is modified. How would you change the distribution of its electrons? Either you give it electrons, or you take electrons, or you can change the distribution of its own electrons, and you can change where the electrons are. These may be achieved by friction, contact, or induction. Okay, this one. Okay, nothing happens as it were. Okay, blah 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 blah. Okay, we know atoms are made up of nucleus and electrons moving around the nucleus and the electron cloud. We know the nucleus is made up of protons and neutrons. Okay, the charge. The charge of any proton is 1.6 times 10 to the power of negative 19 coulombs. You need to memorize these. The charge of electron is actually just the same thing but negative. So 1.6 times 10 to the power of negative 19 coulombs. Okay. The charge of a proton, P, is equal to the charge of the electron, E, which is the absolute value. Huh? This is the absolute value. So the positive value of it is always 1.6 times 10 to the power of negative 19 coulomb. When an atom gains electrons, it becomes a negative ion. If it loses electrons, it becomes a positive ion. Electric charge is quantized. Okay. Similar to radiation. It's quantized such that it only comes in discrete amounts. The SI unit of charge is Coulomb, okay? And 1C is 1 Coulomb. These are the prefixes you must know. Pico is negative 12, nano is negative 9, micro is negative 6, milli is negative 3. Okay. Most of you already know this from before, but عادي. Okay, 1 Coulomb is described as being 6.25 times 10 to the power of 18 elementary charges. Okay, you're going to use this formula here. Q equals N times E. Okay? Q is the charge in coulombs, okay? N is the number of electrons. E, as we said earlier, is the number of electrons. You know, the charge of each electron is negative 1.6 times 10 to the power of negative 19 coulombs, okay? The law of conservation of electric charge, okay? It states that the net amount of electric charge in any process is zero, obviously. If there's positive 6 on the left, there should be negative 6 on the right. That means no electric charge can be created or destroyed. What is the role of charged particles? Conductors allow charges to spread. Why? Because of some of its electrons, they're able to move anywhere within it. Remember, conductors they allow the valence electrons to move. In metals, only electrons can move, nothing else. In an insulator, all electrons are fixed. In conducting liquids, like molten salts and aqueous solutions, they contain ions. When you have ions, both the positive and negative can move. In semiconductors, you don't need to know anything here. It's just memorize it for now. In semiconductors, there are gaps left by electrons that cause the movement and cause conduction. Is it conduction? Yeah, and the conduction, they conduct electricity. When an okay, la 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 la. Okay, here the electroscope. This is a bit important. The electroscope is used to detect a charge. It utilizes the principle of repulsion. Okay, this would be a CA question. The electroscope utilizes the principle of repulsion. How does it work? You have a metal cap. Okay, forget about these. You have a metal cap, you have a metal plate, and you have a gold leaf made out of gold. Why is gold used? Because it is ductile. Ductile meaning it can be changed into wires, it can be cut into small shapes, blah 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 blah. So why is gold used? Because it is ductile. Or they could say, what is the property that gold uses in the electroscope? Just say ductility. Okay. Okay, you have three cases. The electroscope, it's used to detect a charge. You use it to detect if it's positive, negative, or neutral. The case A is to bring a negatively charged plastic to the negatively charged electroscope. Okay, negative charges will flow down to the metal and the gold leaf, and they will repel. Okay, the gold leaf metal plate and they're negative, so they're already repelling. If you get more negative up here, negative will flow down here, so there will be a greater difference. That means it will repel more. Okay, if you bring a positively charged acetate strip, مثلا, it will attract the electrons of the gold and metal strip. No, it will attract. Yeah. So if you got here in case B positive, it's gonna flow in not the positive charge will flow, but it's gonna attack the electrons. So the difference in between the negativeness here will decrease. So that's why the repulsion or it won't repel as much as it was before. Case C, bring your hand near the metal cap. Your hand will absorb the negative charges and decrease the repulsive force between the gold and metal. Okay, same thing, same as case B, where here it decreases the force because it absorbs some electrons. Nafeshi, your hand will absorb electrons because your hand is a large body. This is very important. An increase in the divergence of the gold leaf would show that an object has the same charge as an electroscope. And the charge of electroscope is usually negative. Okay, so if it causes the gold leaf to move away over here, if it causes the gold leaf and metal plate to move away and repel, that means they are the same. So that means the object has the same charge as the electroscope, which is usually negative. Okay, Hella Van de Graaff generator. It's an electrostatic generator. What's it capable of doing? It's capable of producing enormously large static potentials. Okay, it has a rubber belt, two rollers, two brushes, a motor, and a dome. What happens? You have the rubber belt. It flows and there's friction on the belt. When there's friction, there's electrons being released. So they release these electrons outside and it continues flowing with only positive charges. So what happens is these positive charges reach the dome up here and the positive charges will be all building up at the top in the dome. Okay, revealing fingerprints. Okay, connect a power supply to two plates. One plate connected to the positive side of the PSU, making it positive. Apply the powder on the positively charged plate, making the powder positive. On another plate, uh, connect to the negative side of the power unit, making it negative. When the specimen is pressed, the positive powder glass goes up to the negative, where the powder attracts to the tip of the finger and becomes negatively charged. Okay, enough here. Two metal plates. One, two. One is connected to the positive, one is connected to the negative. Okay. We want to apply some powder. Okay, we're going to apply it on the positive charge. Okay. So if you apply the powder on the positive charge, the powder will become أكيد positive, right? ماشي. So the powder becomes positive. Other plate connected to the negative side of the PSU makes this plate here negative, right? Okay. When the specimen's pressed, so when you get your finger, you press with your finger and you put your finger here, you want to do the fingerprint, you put it, it's gonna press it, with a negative will attract the positive, okay? The positive powder goes up to negative, where the powder attracts to the tip of the finger and becomes negatively charged. Electrostatic forces may be used to reveal fingerprints. Okay. Electrostatic precipitator. Okay. It's used to filter smoke and dust. It's made up of positively charged fine wires separated by two earth metal plates. What happens is this is used to filter out smoke and dust. So the air comes up, it meets this fine positive wire. Once it meets it, this fine wire will repel it onto the two plates, so it sticks onto the two plates. Okay. Once it sticks onto the two plates, it just gets stuck. خلاص, the dust and smoke will get stuck on the two plates, and they can only be removed when it's cleaned. هلا here the lightning conductor. Lightning conductors help protect tall buildings from being struck by lightning. I'm sure you guys have seen the one on the Burj Khalifa. During lightning, the clouds are charged, so the tall lightning conductor will absorb the lightning's electrons and pass it through the strong copper strip, which is a very good conductor, and will release those electrons into the earth. Very easy. هيدي electric field not required. Okay, خلاص, we're done the notes. هلا بنعمل quiz. Okay, now we're doing the quiz. Very easy, but there's no calculation questions, so make sure you know the formula in case he does get the calculation tomorrow. Any material that immediately spreads charges, أكيد, if it spreads the charge, conductor. Okay, make sure you come and do the course division. Okay, I won't solve it. ما لي خلق والله, I'm very tired. Charges that cancel each other. Okay, if it cancels, then their magnitudes are equal. Okay, but أكيد opposite in sign. يعني positive cancels with negative. Okay, in metals, only electrons can move, right? In insulators, nothing can move, they're fixed. In liquids, both positive and negative can move. In semiconductors, there's holes. Okay. Question 4. I think this one is wrong. Listen, we got a negatively charged rod brought close to two conducting spheres. Okay, the spheres touch each other. When one of the spheres initially standing further away from the rod is moved away, it carries a charge. This is a heat induction because we're not touching the rod. But this one I think should be negative. Okay, and I asked a few people at school, they told me the same thing. Why? Okay, so here's what they got: a negatively charged rod. Al spheres hon. These spheres are touching. The negatively charged will attract the positive. Okay, if this is attracting the positive, and here what's left is going to be negative. What they did is they took this one that's further away, حطوها على جنب. Okay, so okay, this one should be negative, but I don't know why they put positive. Okay, question 5. Okay, here rod Y will be an insulator. Why? Because it's not repelling. Remember, if it's not repelling, means it's not allowing the charge from the charged glass to repel the wire to flow. Yani we're not allowing it to flow, so that means okay, it's an insulator. Question 6. A balloon is rubbed against a piece of cloth and is brought near a hair. What will the balloon do to the hair? Akid, it will attract it. I'm sure you guys have seen before when you put the balloon above your hair or above your arm hair or whatever, it like makes it stand or it attracts it. Question 7. When rubbed with a piece of cloth, polythene yani plastic, what happens to it? It becomes negative, okay, or negatively charged, and perspex or acetate becomes positively charged. Perspex, acetate, Coulomb, they're examples of glass. Okay, we know it becomes positive. Question 8. Okay, which rod here is considered the conductor? Akid, the metal rod. Obviously metal, but since it's repelling it, so it allowed the charge to flow. And which one is the insulator? Akid, the plastic, because it's not repelling the ball. Question 9. When a charge is shared over two conductors, the electric force, akid, it will decrease, right? If you have a lot of money, you share it among many people, what's going to happen to the value of it? It's going to decrease. So electric force will decrease. Question 10. To earth a charged object means to bring it into contact with a much larger conductor. Again, nothing special. Although charge cannot move through the body of the insulator. Yeah, charge cannot move through the body of what? An insulator. Charge can be slightly displaced within each molecule or atom. Okay, yeah. Resulting in a net induced opposite charge slightly near to the inducing charge. So to explain this is the same thing as the rod and the sphere. Okay, if you have negative, even if this is neutral, what's going to happen? The positive charges will all build up closer. The opposite charge will build up slightly nearer to the inducing charge. This is the induce, yani is something you're adding. Okay, let's say we're adding this. So all the positive will build up nearer to this negative charge, to the induced charge. Okay, and this is a key to all be negative. Okay, so although charge cannot move through the body of the insulator, it can be displaced. Displaced means the positive go to this side, the negative go to this side within each molecule or atom, reducing in a net induced opposite charge slightly near to the, this is the opposite. Okay, this is opposite to this. Yeah, near to the inducing charge. Question 12. Okay, this is a gold leaf electroscope. What is the purpose of the electroscope? We know electroscope is used to measure, not to measure charges, to detect the nature of a charge, to see if it's positive or negative, to detect the presence and the nature of charge, to see if it's positive or negative, and to see the relative magnitude of charge. Relative magnitude means to see if it's a strong charge or a weak charge. Again, if it's a strong charge, it will cause more repulsion. If it's a weak charge, it will cause less repulsion. Question 13. Okay. A rod carrying an unknown charge is brought near a negatively charged electroscope. If the gold leaf diverges more, معناتها it has the same charge as the electroscope. In this case, it's negative. Remember, if it repels, same charge. Diverges, repels, same charge, negative. If the gold leaf diverges less, if they attract each other, so أكيد it will be opposite, so it's going to be positive. If it does not move, zero. بدهاش حلقات. Okay, 14. If two glass rods initially rubbed with silk, they're both going to have the same charge, so repel. Two plastic rods, again, same charge, repel. Plastic rod, glass rod, plastic negative, glass positive, what will happen? Attract. Plastic rod and glass rod brought close without rubbing, so there will be no change in charge. It only gets a charge when it rubs. Okay, so there's no interaction. Question 15. Okay. Describe the process of negatively charging a sphere by induction. Place a neutral sphere on an insulating stand. Bring a positively charged rod close to the sphere. Then earth the sphere quickly. Move the charged rod far away. The sphere is now negatively charged. Okay, so here's what they're saying. Place a neutral sphere. هاي neutral sphere وبجيب a positively charged rod. Positive, positive, positive. What's going to happen? All the negatives will come and dominate now, right? So they're saying earth the sphere quickly. And touch it with your hand or earth it or whatever. That way all the charges will escape. What's going to be left? Only negative charges. Okay, then move this rod far away, whatever. So خلاص, the sphere is now negatively charged. Okay, if you want, read over the notes yourself again. Maybe read over the book. Very, very easy, do course revision. Other than that, thank you so much for watching. Good luck.